In the previous video, we introduced ourselves to the tangent ratio. And we said that the tangent of A is the opposite over the adjacent. Alright, so in this video, we're going to look at a couple of more trigonometry ratios. In these initial lessons, we're only going to look at 3 total. There are actually 6 total, but that will be for later on. So let's go ahead and look at our other ratios. Let's get our triangle. So here is our triangle that we worked with. Here's A, here's B, here's angle C. That's supposed to be a right angle. Okay, so that means side C is the hypotenuse. Side A was the opposite. And side B was the adjacent. All right, so we already know that tangent of A is opposite over adjacent, and we are focusing on this A for right now. But do remember, if we focus on B, the adjacent and the opposite do switch. And the next ratio we're going to learn is it's called the sine ratio. And so the sine of angle A is going to equal, and so for this ratio, we're going to look at the ratio of the length of the opposite leg over the length of the hypotenuse. The opposite leg divided by the length of the hypotenuse. Okay, now we do abbreviate this. What we write is the sine of A, S-I-N of A, equals the opposite over the hypotenuse. Good. Okay, now we have another ratio. We're going to call it the cosine ratio. And in this case, the cosine of angle A is going to equal, so here's the angle A, the cosine we define as the adjacent over the hypotenuse. So it is the length of the adjacent leg all over the length of the hypotenuse. And we do abbreviate this one also. So we write the cosine of A equals the adjacent over the hypotenuse. Good. Okay, so remember, when we have these tangent, sine, and cosine ratios, these are defined by humans, and it's just a way to keep track of what side lengths we're talking about and the ratio of those side lengths. Now, there is a reason we do have 3 main ones, and the reason is because, when you have 3 sides of a triangle and you're creating a combination of 2 of them, how many different ways can that happen? Well, it can happen 3 ways. So we need the 3 ratios because no matter which 2 sides you're working with, one of the ratios work. You see, with the tangent, it was only the adjacent and the hypotenuse. Well, what happened if we needed the opposite and the adjacent? Well, what happens if we needed to have something with the hypotenuse? Well, we didn't have one with the hypotenuse, so now we have 2 of them with the hypotenuse. So if we're working with these 2 sides, opposite and adjacent, it's tangent. If we're working with opposite and hypotenuse, it's sine. If we're working with adjacent and hypotenuse, it is cosine. And so the 3 ratios allow us to handle any combination that comes up of 2 sides. Okay, so let's look at an example of using our new ratios. And let's say we have this triangle here. Let's say this is A, B, C. This is going to be our right angle. This is 85, 75, and 40. All right, so we want to find the sine of A and sine of B. So the sine of angle A. So sine is opposite over hypotenuse. So if this is angle A, the opposite side is 40. And the hypotenuse is 85. And let's see here, what can we divide that by? I think we can divide each of those by 5. So it becomes 8 over 17. And I don't know what that equals, so let's go ahead and get out our calculator. 8 divided by 17 is 0.4706. And then the sine of B, let's see here, here's angle B, so the side that's opposite is 75, and the hypotenuse is still 85. And that becomes 15 over 17, which is approximately, let's see here, 15 divided by 17 is approximately 0.8824. Good. All right, well, let's do the same thing with cosine. Let's find the cosine of A and cosine of B. Okay. So the cosine of A, all right, now here's A, and cosine is adjacent over hypotenuse. So the side adjacent is the 75, and the hypotenuse never changes. So that becomes 75 over 85, which is 15 over 17, which is approximately 0.8824. And then the cosine of B, well, here's B, and cosine is adjacent over the hypotenuse, so that is 40 over 85, which is 8 over 17, and that is approximately 0.4706. Okay, now right away you guys have seen that these are the same and these are the same. And there is a reason for that, and we'll get to that later on in class. We're not going to talk about that right now. But don't be surprised when there is that similarity between sine and cosine ratios, but it has to do with different angles, so do keep tabs of that. Because notice that the sine of A and the cosine of B are the same, and the cosine of A and the sine of B are the same. Okay, so here's our three ratios now. Here's an example using sine and cosine. Now, of course, there comes this question of, well, how do we remember these ratios? Because you do have to remember. I mean, they have to be pretty much, in your memory somewhere, almost inherent. So not something that you look up every time. And so one that is very, very common is this little acronym here. It's SOHCAHTOA. So you'll probably hear people say SOHCAHTOA. And what that means is the S stands for sine. So the sine is the opposite over the hypotenuse. The C is the cosine, which is the adjacent over the hypotenuse. And T is the tangent, which is opposite over adjacent. So it's a nice little trick to kind of keep track of, the different ratios. I don't really use this, but if you need to kind of always say SOHCAHTOA every time you need one of the ratios, that is okay, because it kind of helps you keep track of the different ratios. All right, let's do a couple more examples here. So in this example, let's say we want to have this triangle here. Okay, that's a right angle. This is 44 degrees. This is x, and this is 14. And we want to find the value of x. Okay, so in order to do that, the first thing that I always do is I look at my angle. Here's my 44 degrees, and then I figure out which sides am I working with. Okay, well this 14, that's a hypotenuse because that's opposite the right angle. And then this side here, well that's opposite the 44 degrees. So we're working with opposite and hypotenuse. So the opposite and hypotenuse, well that's the sine ratio. So I know that the sine of 44 degrees is the opposite over the hypotenuse. So the sine of 44 degrees is x over 14. So there's the setup. So now that we have more than one ratio, you see in the previous video we only had the tangent, so you always knew you were going to use that. Now, when you do the homework or you have future problems, you got to figure out which ratio you're using. And so we figured out that based on the 44-degree angle, we were able to use the sine. Okay, we multiply each side by 14 and we get x equals 14 times the sine of 44 degrees. We go to our chart. Now this is a little, we have to actually look at our whole chart. So remember, our chart has the acute angle over here, and then we have the sine ratio, the cosine ratio, and the tangent ratio. So when we go to 44 degrees, which is down here, the sine ratio is 0.6947. So let's go ahead and put that in there. So x is going to equal 14 times 0.6947. And so when we put that in our calculator, so let's see here, 14 times 0.6947. And that is 9.7258. And there is the length of that side over here. Let's do another one. Let's look at this example here. Let's say we have this triangle. There's a right angle. That is 26 degrees. This is 17. This is x. And we want to find the value of x. Okay, so to find the value of x, we first start off with what ratio do we need? Now, of course, you could probably guess because we've done the other ones. But anyways, let's go through the exercise. Here's our 26 degrees right there. Okay, now this side here, it's right next to it, so that's the adjacent. This side here is the hypotenuse. So you have to think what ratio uses adjacent and hypotenuse, and that is the cosine ratio. So that means the cosine of 26 degrees is the adjacent over the hypotenuse. It's supposed to be a 2. So that means the cosine of 26 degrees, the adjacent is 17, and the hypotenuse is x. So that's the first thing you need to do. You need to set up your trig ratio. You got to figure out what sides we're dealing with compared to the acute angle, and then you need to figure out which trig ratio to use from that. Okay, so let's solve for x. We'll multiply each side by x. So x times the cosine of 26 degrees equals 17. Divide each side by cosine. So it's 17 over the cosine of 26 degrees. So that means we get 17 over, and we go to our nice trig ratio table. And what do we have? We have 26 degrees, so that's right here. We go to the cosine, which is 0.8988. So let's write that in there. 0.8988. So x ends up being 17 divided by 0.8988, and that equals 18.9141. And there is our answer.